So hi guys, let's continue quickly about these revision questions. So independent variable, that is change. If I write here, that is change by you. So that's the answer. If I go for dependent variable, so dependent variable, of course, what we can do, that is measure or observed. So measured or observed. So that's a thing, and or observed. Then we go for control variable. Of course, you kept the same control variable. So if we go kept the same, so that's the answer for quantitative. We discussed in the class, that is always measured in numbers. So measured in numbers. And if we go for qualitative, so qualitative again is the characteristics we said. It's rather than numbers we say about that. So if we talk about data or observation, that's the thing. So you say, observation described in words. So we can say described in words, the color and these sort of thing. So that's qualitative. If we talk about repeatable, so it means if the same person gets similar result, so do it again to similar result or whatever the thing, it's repeatable. So similar result is repeated. So that's accuracy, how close a measurement or result. So if I say how close a measurement, so that should be the answer for this question. Now a student is investigating, and we have done this sort of question before, so you guys know that thing, how to do these questions. If we talk about this one, so first question, they say it's a bouncing height. We did this thing in the lab. So if you want to do this thing, this is a straightforward answer. So it's a drop height. And this one, what is a dependent variable? You talk about the bounce height. So this one is bounce height. And what are the control variables in this question? We talk about the type of the balls. So type of balls. Or even you can say size of the ball or quality of the ball, we can say that thing. So what is the hypothesis? We say here that the drop height is increased. So of course that bounce height, the bounce height also increase. The control variables kept the same, so you guys know that thing, control variables are kept the same to make sure that only the independent variables affects the result. This helps to make the experiment fair and reliable, so the outcome is not influenced by other factors. So I can say quickly the answer, I don't have to write that much detail. So it means it can increase the reliability. So increase the reliability. And which variables goes on x-axis? Of course, we know independent variables. The first one, this should be on x-axis, and of course this should be on the y-axis. So oops, it should be on the y-axis there. Now, so I can say independent is x-axis and dependent is equal to y-axis, is equal to, we can say, y-axis. Now if we come to the graph question number 3, it's very straightforward. I already have just plotted the lines here because x-axis temperature is over here, y-axis is average germination rate, and let's see how we can draw the graph. So 0 0 first reading, so I can say, I can plot the graph 0 0 here, then I have 5 and 5, so 5 in the middle, and I believe somewhere in the middle 5 here, somewhere here, and then we have 10 15, so 10 is here and 15 somewhere again in the middle here. This is 10 15, and we have 20 30, so we have 20 and 30 should be here, and we have got the last point 30 40, so 30 is here and 40 somewhere here. So try to fit the best fit line. If I can draw it again, it's difficult to draw the straight line, but somehow if I just draw it again, if I draw this line, because this is the best one, we are meeting it here, all right? So somehow we have the fractional here. I think that probably I would say is anomalous reading here, we got it, but I think this line fairly, if we have 20 30, fine. So this is the best fit line we have got here in this question. So moving on, what temperature would be required for germination of 35%? So of course, so we know we are talking about a germination rate, which is percentage over here. 35 should be somewhere here. So if I draw the line here and then come to the line here, oops, shouldn't be. So somewhere, it's still not in the middle, somewhere I think in the middle, if I can say. Somewhere in the middle we have got roughly, should be before 25, or probably I can go back for the lines. We are talking about the 35%, 35 is somewhere here, and I can draw the line here. So now if I plot the line here, so somewhere you can say roughly 24 25 is the answer for that question. 24 or 25, in between this range, degrees Celsius, we can say the answer should be there, centigrade. Now conclusion, you can say what's the conclusion for this one you got here. You can say again, it's a straight line. Whenever there's a straight line, we talk about the positive correlation as a directly proportional. So if you're increasing the temperature, the average germination rate increase. So it means I can write here, in fact I can say in this way, increasing temperature will increase the germination rate. Ignore this T capital, should be lowercase, but I'm just trying to make sure I place this thing on, post this thing on elements so you can basically see it later. All right, if we go to question number 6 here, now is need to change centimeter to kilometer. let's see here. For example, if I am talking about changing kilometer to centimeter, and that will give it to you multiply by 100,000, I guess, or we can say is equal to 10 power 5, right? 1 to the 5. And if we want to convert from centimeter to kilometer, and that will be divided by same number 2, 3, 4, 5, 3, 4 and 5. So now this is the thing. So it means if we want to change centimeter to kilometer, you have to divide by 1, 2, 3, 4, 5, and answer, of course, when you do this thing, you will get 300,000 divided by 100,000. I'm sure that would be 3 kilometer answer. Now kilometer to meter, so small as similar things. So if we have kilometer to meter, what thing changes here? If I say kilometer to meter, that will give you one more zero. You can add it 1, 2, 3, 4, 5, 6. You multiply with, and you do meter to kilometer, and that give you divided by the same number 1, 2, 3, 4, 5, 6. And now because we are doing kilometer to meter, so you can understand that in this case we have to 0.04 multiply by these 6 zeros. So we multiply by 1, 2, 3, 4, 5, 6, and that should be equal to 40,000 millimeter. Hours to second is very easy, because hours to minute, minutes to second, so we have to multiply 2.5 by 3,600. And if you use your calculator, which I am using right now, so it's 9,000 seconds here. Now we come to part D, where we have to do millimeter to meter. So millimeter meter, again we have to think about it, what we are doing. So in this case we have to divide by 1,000, because millimeter is small number, meter is a bigger number. Should be dividing by 1,000, and that will be, I think, straight away 3.5 meter is the answer. So hope it's clear. I'm trying to explain, otherwise it will be messy. It's a bit messy, but I hope you understand that. So 25 meter per second to kilometer per hour, so you can understand easily 25. If I use text here, maybe 25 meter, okay, and per second. So if I per second means if I say divided by, hopefully, second, so I can change this thing, 25 meter per second. So 25 meter per second, and of course what I need to do, because meter to kilometer, so I should be dividing by 1,000, that meters to kilometer, and then of course what will happen, multiply by seconds to hours, so 60 times 60, 3,600 to 25 times so I think better if I use this pen here. So 25 times 3,600 and divided by 1,000. That's the thing, and that probably, if I use calculator, I'm getting the answer 90 kilometer per hour. So that's a calculation for this question. I'll try to make it more or less messy so you can understand easily, but I think I tried to explain it the time I'm explaining. Hopefully you understand that. You need to re-watch the video again and again to make sure it makes sense to you. Following the scientific notation 10 power, so it means the decimal is here, so 1, 2, 3, so I should be having 5.201 into 10 power 3. And if I use text here, let's say, does it work or not? So if I'm having this one, so again 0 decimals of 1, so say 1, 2, 3, 4, 5. So if I write here 1.1.00100, times 10 power 5. I don't know whether you can write 5 there, or 10 power 5 or not. So 10 power 5, if I write here, that would be the answer in that case. Now here we're going forward. So 1, 2, 3, 4, 5, and 6. So we don't want to do this thing. We need to make sure we come near the numbers. So 1, 2, 3, 4. So 5.06 into how many? The 4. I think 5.06 into 10 power minus 4. That should be the answer. And this is, of course, we can say 1, 2. So 4.1 and 10 power minus 2. That should be the answer. So this is the question here. Now we come to the other way around for this one. So we need to convert the following to standard form. So I'm sorry, we need to put the decimal. So we have 3, so it means 1, 2, and 3. So it means it should be 5080. 5080. That should be the answer. And if I do this next one, it is for example, if we talk about 8.4 10 power minus 1, so we go back, so it should be 0.84. That should be the answer. And if the third one is 10 power 6, so we move 6 times over there. So it means what will happen? So I believe it should be 199. So that means be 1 2. So we have 4 zeros. 1 2 3 4. That would be the answer for that. So now next one, 6.08 10 power minus 3. We go 3 decimal places behind. So it should be, the answer should be 0.006008, and you can easily understand that thing. So because decimal was with 6, so 1 2 and 3. So that should be the answer for that question. We have done this thing a lot, scalars and vector. So vectors are all scalars need scalars need magnitude and unit. So just say if you're buying 2 kg of mangoes, of course that means this magnitude and unit is there. So that is a scalar quantity. And the vectors we talk about, vectors need one more thing. Vectors need magnitude, unit, and direction. So let me correct this thing. So magnitude, unit, and direction. And now if you need to see the next example here. So vectors need magnitude. So if we talk about a label, we have got different quantities here, and we need to make sure that we write scalar and vector for that thing. So I'm just correcting this question for vectors. Okay, we have to label this one. So it means the mass does not need direction, of course, straight away. This is a scalar. Volume is no direction needed, so scalar. So is scalar. And force, of course, force need direction, we talk about, and then force is vector. Displacement, of course, you know the thing, displacement is needing direction, so it is also vector. So we talk about vectors here. Velocity, again, it needs direction. Velocity is a change in speed divided by time change, and that needs direction. Of course, that is also a vector. And as I mentioned, speed is not needing anything. direction, so that's why velocity is also speed is also a scalar. So this is also a scalar here. All right, let's go to the next question. What's the difference between distance and displacement? So distance, again, we talk about distance is scalar. I think we discussed here further. No, it's not there. But displacement is mentioned is velocity. Displacement is a vector quantity. Vector quantity, and we talk about the distance is just as vector quantity, and of course displacement measures a change in position. If you want to write something further, it measures change in position. And if we talk about the distance here, so if I write about distance, so distance is all the length of the journey is a scalar quantity. So distance is scalar quantity, and measures the length. So I will correct if there's a spelling mistake there before I post two elements. I will basically make sure the spellings are correct, so you don't get confused here. All right, to the page, next page, question number 12, which is very straightforward question. Abdullah runs 2 laps around the school, so each lap is 200 meters, and we are talking about distance. Of course, 2 laps, 2 times 200. If I want to write it, 2 times 200, that should be is equal to 400 meter. So just let me 400 meter should be the answer in that case. Then what's the displacement? As you read it, he ended in the same place he started. 200 minus 200 is equal to 0. So that is, we have got 0 meter is the answer for that question. Now, moving forward, if we go to the next question, which is a graph here, and you need to see the graph is being just divided into different parts, A, B, C, D. And we have to, first of all, discuss the motion of the graph. And if you talk about the motion of the graph first, so you can see clearly, we are talking about a truck's journey. And if you see overall, this A1 is this area. If I want to, this area is basically we talking about here. It moves forward. I mean, that's the positive direction from 0 to 10 seconds, and then stays in between 10 to 15 here. If we talk about here, it stays still here in this area, and then we have got a negative direction that moves backwards 15 to 20 seconds. So now this graph tells you, now if we want to write something about the graph, we have to explain that thing. So I can say the truck moves forward direction, and it's from 0 to 10 seconds is 0 to 10 seconds. And then we talk about it stays still, as in 10 to 15 seconds. And then we have the moves backward. So let me say moves backward, and it moves backward from, I think, 15 to 20 seconds. seconds. So that's the thing you probably need to discover. You can write in a paragraph, but I think just try to explain here. Now, what are the in time intervals in the truck doing the falling? So positive velocity, as already mentioned here, when we're talking about this is 0 to 10 seconds, and then we talk about 10 seconds. And when we talk about the stationary, it's very easy. You can see the C area, which is basically 10 to 15 seconds. And then when we talk about the last one, the negative velocity, which is very easy to understand, which is 15 to 20 seconds. (15 to 20 seconds). 20 seconds. All right, I missed the stationary was, which was stationary was 10 to 15 seconds. So these are answers for this question. What's the velocity of the truck from 0 to 5 seconds? And now this is, we need to go back for question C. Now 0 to 5 seconds, we can draw the graph here, the triangle. Let's see that if I use this one. And of course straight line here. So it's not 100% accurate because I just couldn't meet the point, but if I try to meet the point more accurately, yes, and then oops. So now this is a triangle here. So now in this triangle you can see that thing. We have options. Either we have the formula, we can write y2 minus y1, the formula, or over x2 minus x1, or we know slope is always equal to y over x. So both cases you can do this thing. So if I want to erase and write the answers here for you guys, now here we have got first one. If I take this side, so if I take this side, this is 10 meter, all right? I can say 10 meter here, and this is 5 seconds here. So if I want to take the slope of this area, is should be then 10 over 5. So if I want to write here 10 over 5, which is equal to 2 meter per second, okay? Or you can do y2 minus y15 and x2 minus x1. You can do that thing and you get the same answer in that case. But let's go to the velocity of the truck from 10 to 15 second. So 10 to 15 second here, I think that this area should be 0, so that should be 0 meter per second. And we are talking about the 15 to 20 meter. So 15, 20 meter, this should be, when I draw the graph here, 15 to 20 meter. That's the thing. So now we have got 15 to 20 meter, that we can see that thing here. We have got, so as I mentioned about the graph here, so we have y2 and y1. So y2 we have the formula as I mentioned before, that slope is equal to, if I want to write, slope is equal to y2 minus y1 divided by x2 minus x1. So my y2 is equal to here, we have got minus 5, we can go there. So minus 5 here, this is y2, and so if I write here minus 5, and this is, we have got minus 15, this is y1 is, this one is 15, so minus 15 divided by x2 we have got 20, so 20 minus 15, that should be equal to 20 over 5 minus 20 over 5, which is equal to 4. So if I just clear up this thing so you understand that, so we have got minus 4, which you can easily understand why is minus 4, because it's a negative slope. So minus 4 meter per second is the answer for that question. Moving forward, if we see what's the overall distance, so now we have to see the overall. So we were talking about question part F, which is what is the overall distance traveled from 0 to 20 seconds. If we can go back to graph, we can see 0 to 0 to 10 seconds and 10 15 seconds. We have got total distance from here, the 15 seconds. So I can write here 15. If I want to write here 15 here, then plus 0, because there's no movement in that one, 0, and then again if it come back, so we can see 5 10 15 20, so it means 20 meter, and that will be overall 35 meter is the answer for that question. We move to the next page here, and next page says here, what is the overall displacement? Now we talk about displacement, and we just discussed about the distance. So overall displacement, if I go back this one, so you need to know this thing. This is displacement is equal to, if I write here, displacement is equal to, if you remember that thing we have done in unit 5, is equal to unit 7, I guess, is equal to final minus initial position. That's the thing we should know. All right, so which is equal to, we have got minus 5 meter. If you look at the graph, minus 5 meter and minus 0 meter, which is equal to, give you the answer minus 5 meter, the answer for this question here. Now next question is asked you again that a different truck. Now what does the slope of the position time graph explains? Of course, position time we straight away we can talk about, that is velocity. Velocity is the answer here. Now the next question we talk about, a different truck travels at a velocity of 50 kilometer per hour for 1.5 hour. What is the displacement? So we know that thing, that velocity is equal to, let's write this one. So velocity is equal to change the displacement over time, which is equal to, we need to find displacement here. So it means, so we have delta x is equal to v times t, and v we have got 50 times t, we have 1.5. So the answer should be, if I use 50 times 1.5, should be 7.5 or 75, if I just am not wrong, 75 kilometer, because we're talking about the displacement is the answer for that. Now if we talk about the next one, so motorbikes travels at a velocity is given to you, that is 20 meter per second, and we need to change again displacement to displacement. Delta x is equal to 20 times 80, which is equal to 1600 meters answer. And what is the velocity of a truck that travels 500 meter in 2 minutes? So you need to, so we have meters and minutes, so I probably would change this minutes into seconds. So 2 times 60 is equal to 120 seconds, and then I have straightforward formulas. So velocity is equal to t, and I need to find 500 divided by 120, 0 cancel, 4.17 meter per second. Define equilibrium. I mean, equilibrium, we just doing this one like sum of all forces, I mean, equal to 0. So if I want to write this then that this sign is equal to 0, I mean it doesn't, but I can probably type in this one, summation of f is equal to 0. So I can write that here. For example, if I want to write the definition, sum of forces equals 0. So that's basically equilibrium. And if we talk about the moment in that case, let's say if we am talking about a moment, so it means how would we say the moment? Sum of moments. So if I have to use sum of moments around the pivot. So if we have the pivot here, for example, like this, a straight line. So if we have the, sorry, so pivot, we're talking about this one. So if we have a pivot here like this, so this is called the pivot here. That's what I'm trying to explain to you. So it means sum of moments around the pivot should be equal to 0. So that should be the answer for this question. I'm just not doing the very good grammatical English over here, just trying to explain you here, but you can correct it. A should be smaller in that case, and T also smaller. Define what a load and reaction forces are. You know that thing, load, tension, forces, all these things are equal. So it means load, I can say load is equal to force applied. Remember, I think we have done different practical for that thing. So load is equal to force applied for that thing. I mean, to any object, to anything, any item like weight. So if I want to write here applied to an object. And for example, if we talk about reaction force, we say that thing R. So if I want to R here, R is equal to, is just to create, it's just basically to support. Reaction force is equal to support, is equal to support, is support load overall, I can say. It's the opposite of that one, support load. That reaction force we have, I think I missed that one when we're talking about the load. So load is equal to force applied to an object. I think that thing I wrote earlier. So R is the reaction force which is created by an object to support loads. That normally happens in this question. The draw a free body diagram for a box on the floor. For a box on the floor, so it means what we can see, a box on the floor. This is the box. All right. So the box we have got. So of course this is your two forces, and we are talking about we just put the load here. If you remember that thing, just do this thing of weight here. So weight is in newtons, and then of course we have the this is the reaction force, which you also sometimes call normal. So that's it. And this is also, remember, I think when you just hang the weight, which is, this is, we're talking about the load. So this is also called load here. All right, guys, let's go to question number 2021 here. So if we are talking about what is equilibrium, or what is definition of equilibrium. So it means all the forces, if I want to write all the forces, I mean all the forces acting on that one, and acting on object, I can say acting on object, are balanced, we can say. So technically my statement is not correct, grammatically is not correct. All the forces acting on an object. So it means if I have to are balanced, and this shouldn't be t over here. That's the thing we talk about, the equilibrium. I mean, overall there is no change in motion when we talk about equilibrium here. In simple terms, we can say the object is either at rest or moving at a constant speed in a straight line. That's called equilibrium. So if you can if you want to just write something extra, you can repeat the video and you can check it. What's the detailed answer in that case? Question number 21 here. We have 50 Newton and this force is given to us. You need to understand one thing, that because the angle is similar here, 45, 45, so I expect this is also 50 Newton here, straightforward. And I have the formula which is hypotenuse square is equal to adjacent square plus opposite square, which means F1 square is equal to this 50 Newton square plus 50 Newton square. So my answer should be overall 50 square plus 50 square is equal to F1 square. And if you use calculator, I'm sure you can do that. I think you just don't want to write too much things on that one. So you can get F1 is equal to 70.7 Newton. That's the answer. So same thing over here, but now slightly different condition, because they have already given you the hypotenuse, which is 150. But we know F2 and F2 both are same. I can say X here, also X here. So it means my equation should be here 150 Newton, 150 square is equal to X square plus X square. So it means I should have 2X square is equal to 150 square. And of course, you can do the calculation. For 150 square, the answer you get it divided by 2. And you take the under root, you get the answer 106 roughly Newton. So that is the answer for your F2. So both places F2 we have 106 Newton. Now if we talk about question number 3 here, so we have the same thing. So 45 angles, so it means if I have 250 here, I'm expecting 250 here also Newton. So it means I think 250 square plus 250 square is equal to F3 square. And when you just take the square and find the root for that one, the answer should be F3 is equal to 353 Newton. That's the answer for this question. This is very straightforward. 5 minus 5 is 0. Question number 22. And 8 minus 2 6. Of course this is going more, that means 6 Newton in this direction, because this 5 of 0. Question number 23 we talk about, you need to understand F1 should be equal to 50. So that's a straightforward. F1 is equal to 50 Newton here, because equal and opposite there. We have total here 150 plus 50 Newton is equal to 200 Newton. This should be 200 as well, but it's 50 plus 50, 100. So that means for F2 should be straight away. Let me write it more clearly, 100 Newton, because 50 plus 50, 100 plus 100, 200 Newton is the answer, which is there. And if we talk about the positive and negative moments here, so positive and negative moments, we know the thing, positive moment is always anti-clockwise. So when we take a clock here, so when this is moving in this direction, this is clockwise, and anti-clockwise is going other way around, so that is anti-clockwise. I'll make it more better for you. If I talk about the shapes here, anyway, so if I talk about a clock here, so it means in this shape. So when we talk about this direction, so this is clockwise. When we talk about the opposite direction, I can change the color here. If it all, so that is anti-clockwise here. So clockwise, come back to right here. Clockwise is always is equal to negative, and anti-clockwise so anti-clockwise So that's the answer for this question we have. So I write here A for, oops, sorry. So A for this one anti-clockwise, and I can move here, and this is clockwise. So this is clockwise. Okay, let's move to the next page. If we go on to the next page, this question, and in this question we have got step moments. I mean, we just work hard a lot for these type of questions, and one thing is straightforward. You need to understand that thing. We need to again think about the equilibrium and calculate the missing forces here. So if I say straight away in this question, which I just pick quickly, students try to understand is we have, if we take F2, if I take F2, it should be straight away multiplied by 25. So it means I can write clearly here F2 multiplied by 25, and I need to come to green, is equal to, now we have got left with this 515. So it means straightforward. I'm sorry, 500 times 15, and when you calculate that thing, divide 25 both sides, you get the answer is equal to, I'm just using my calculator, 15, 25, and that is equal to 300 Newton. So you've got we have got total 500 and we have got 300. 500 minus 300 should be is equal to 200 Newton. So my F1 is equal to 200 Newton and my F2 is equal to 300 Newton. All right, go to the next question here. Next question, not difficult, it's easy. Only one thing I need to understand, I need to figure out how much from here to there. So if I draw the line here, so how much is this distance, which, and I figure I can easily do this thing. Total is 60 meter, 9 meters already traveled that side, which means of course this is 51 meter I've got here. All right, so if I got 51 meter over here, things are easy again. I told you straight away, just pick the F2 here. So F2 times 60 and is equal to, we know this is 750 Newton. So I write 750 straight away, and I got the difference between here to this is 51. I need to use my calculator after dividing 60 both side, and that will be F2 is equal to, and I'm just using calculator now, 50 times 51 is equal to 637 or 638, 637.5 I'm getting it Newton. So now what happens here, you need to calculate both. We got F2, so you should be subtracting in that thing from minus 637 to 6. So 750 minus 637.50, so that is giving you 112.50. so this is my F1. So hopefully is this okay. All right, let's go to question number 27. Bit tricky, but it's very straightforward. If you remember that thing, the last question we were talking about, we did this question and we got the value for F1 is equal to something like 637.5, and F1, this is F1, I just did not write it F1, this is F1. So I mean this is F1 here, now is 112.50. What the question asking here in this one is asked if what would be the change when person walks to the left, the other way around, it was doing this thing. So very straightforward. Of course we understand that things will change, turn the table around. It means F1, the upward force on the left support increases because the person weight moves closer to that side. So F1 of course increases, and F2, the upward force on the right support will decrease because less of the person weight is acting on that side. So in summary, we can say, we can write it here in summary, we can write it here that as a person walks left side, and mean walks left, if the person walks on the left side, so in the left side, so it means what will happen? So F1 increases. So F1, I can write increases, we can understand that thing. And then what happens in the case of the F2 decreases. Now remember one thing, that total upward force is F1 plus F2 stays equal, which is, I think it was 750 Newton there. That's the question. And now here we have area of circle. So you need to remember that a few things. Area of circle is equal to A is equal to pi r square, the formula, and of course radius is equal to diameter divided by 2. This is we will start. So area of circle with diameter 10, so it means we have to find area, which is pi r square, and pi times r, we have got 5 square, so 25 pi. So if you use the calculator, find the 25 pi, 25 multiplied by 3.4. I'm using my calculator, so it is 78.5 and centimeter square. Similarly here already, it's already given to you. So area is equal to pi, and r we have 7 square, which is 49. So 49 pi, which is equal to 154, I can, if I centimeter square. Cross sectional area, yeah, we talk about area of 7 centimeter. That means again A is equal to pi r square, and this time what we have got here, area is equal to pi r square. So it is 7 centimeter. So radius is equal to 7 divided by 2, which is 3.5, I believe. Yes, 3.5 centimeters. So it means we should have 3.5 square. Area is equal to 3.5 square pi, and check the answer. It is 38.5 centimeter square. Force required to spread, we know the that Hooke's law states F is equal to kx, and we need to find the force. K we have got 50 Newton per meter times 2.5, which is straight away 125 Newton we have got here. Extension, so we know extension is equal to x or E. So we need to find this kind of x is equal to, if I have the triangle formula, which is work for both. So we have F, K and X. This should be divided, this should be divided, this should be multiplied. So if I want to find X, so X is equal to F over K, and F I have got is equal to 500, and I have got 25 to the 50. So I should be having 20 meter, I guess, because this one is in meter. Yes, so 20 meter is the answer for this question. Now 31, if we say truck of weighing 25,000 Newton, so weight is given to you 25% per 4 articles. So it means straight away what I would do, I will divide force is equal to 25,000 divided by 4. 4 6 are 24 to, I think 625. Yes, I think 6250 Newton. And we again need to find that compression or extension. So again same thing, X is equal to F over K, and we have 6250 divided by 20,000, I guess. And wait, yes, it's coming 0.3125 meter. Yeah, we have to keep in the meter. All right, so 0.1 meter. That's the answer for this question. If we move forward for this one. Now if we talk about the gradient, and you guys always remember that gradient or slope is equal to y over x. So if I take a line here, y over x, so it means that will be my slope. So if I just take this thing, how much is it? 25, is it? 25 divided by 1. So 25 divided by 1. So I want to calculate gradient. So it means force over extension. We talking about a force over extension, which is equal to K. We know the formula because K is equal to F over X. So it means my answer should be, what is the slope? Mean in the graph here, I think it should be spring constant. Which is K. And now calculate the slope. So I already calculated. So K is equal to F. We have got 25, and we have got K is X is equal to 1, which is 25 Newton per meter is answer. And how do you know? It's straight up, because you see this line is having a straight. And I told you many times in the class, if a straight line is always as a Hooke's law. So straight line obeys Hooke's law. Draw a line to show how material that has a larger spring constant. So if we see if a larger spring constant, it means it will be more steeper. If you want to have this one, so instead of going this way, it will go probably this way, I guess. So that probably the answer for this one. Can I do this one? What is meant by brittle material? And I'm discussing in the class in the brittle material. We had two things, and one is called quickly broken. One is basically takes time, can stretch. So that's the thing here. So if we what is meant by a ductile material, I'm sorry, I think I put the wrong arrow here. This should be here. So this answer. First for ductile. Ductile is a material that basically which can be stretched easily and turned to the shape of wires and stuff. For example, if you see so many wires which contain copper material, copper is very ductile material. So ductile materials, they can be stretched. So I can say can be stretched, changing the shape of wire. They have a lot of capability to basically before they just get broken. And this is ductile and brittle, which is opposite of this thing. So it is it does not prominently stretch before breaking. This is the answer for this one. And we're moving forward. We have the last page left for this one, and this we have done many times, tons of time in the class. So I'm sure you guys are okay with that one. So what we do, question says, label the following graph with the following elastic region. Then we have the plastic region, the limit of elasticity, tensile strength, and fracture point. So I got straight away this fracture point. It's easily for me. This is, I write FP, which is fracture point. Easy peasy. Of course, I start with the easy stuff. Then I go for the one which is elastic region. So elastic region, we say in that one, we have elastic and plastic. So whichever goes straight line here, if I change the, that's okay. which goes a straight line. This, if I make, oh sorry, if I make a straight line here, this region, this is my elastic region. All right, now wherever we have finishing of the straight section, okay, so that will be my, I mean this area. For example, if I'm talking about this one, this area is my limit of elasticity, so I can say LE, that is limit of elasticity. I can try to put arrow here, yeah, so limit of elasticity. And tensile strength, I mean in any of the curve, the highest point, which is probably this one, is tensile strength we have got here. All right, anything else left? 1 2 3 4 5, is it? 1 2 3 4, which one I missed so far? Fracture point, I've done it. I've done tensile strength, I've done limit of elasticity. Plastic region, okay, I've just missed the plastic region. So plastic region start from the area after limit of elasticity. So this area, if I say color maybe red, this area, if I say here, oh, this is red and red, so I will remove the color, so I'll say blue. So this area is called the plastic region. All right, the curve area, we can say is plastic region here. Okay, so now on the same stress strain graph, for draw a line to show a more brittle. Okay, so of course my brittle should be, if I draw a line, let me take the color here, I take this color, so should be somewhere here, that should be your more brittle line, and I can draw the graph here. What is the difference between elastic and plastic deformation? Because if you remember that thing, elastic deformation, elastic can go back to its original place, the plastic cannot. So if you can stretch a plastic thing at your home and you see you can keep stretching, it cannot go back to the original shape. But the elastic one, which is just like catapult, you use it, you just elastic and it goes back to its original position. So it means if I say EF, let me change the color. So if I go for EF, which is ED, sorry, elastic deformation, it means that thing it can go back to the original shape, and we say plastic deformation, it does not. I hope you understand, it does not go to back to its original position. A wire of cross-sectional area 0.5 meter square extends from 25 to 34. So we need to find the strain, and strain, you know this thing very well, stress strain. So we are finding the strain here. So strain is equal to change in length and divided by change in length divided by original length, and change in length should be 34 minus 25, which is 9, and divided by original length is equal to 25. 9 divided by 25 is equal to wait, let me check. So it should be 0.336. all right, and because remember that thing, there's no unit for the strain because it's a ratio of the length, so there is no unit for the strain. Is stress, we talk about stress is equal to force over area, which is also equal to Pascal the unit, and also equal to Newton per meter. And we have got 500 for the force. Area we got how much? Oh sorry, I missed it. Is 0.5 meter square. This is the area, sorry. 0.5 meter square, and when you calculate, it's easy. 5 should be 1000 Pascal or Newton per meter. All right, and you need to explain how the stress of a material changes changes with the changing in its cross-sectional area. So we talking about a stress is equal, which is this one is stresses. Okay, so if we talk about a stress, which is equal to force over area, it's inversely proportional to each other, because when a stress increase if area increases, then what happened, the stress we have got, which is this is stress, all right, a stress, it is decreases. All right, that's the link between them. Hopefully you understand everything. You can always come back to me if you don't understand. I will try to just put all this thing on a